So this is a third question from your sample midterm exam. So this is a capacity analysis based cost and effect analysis. Okay, so in other words, you have to done your capacity analysis first in order to run the second phase analysis where you would require all these information from your capacity analysis. Okay, so when you are provided with this type of information, which obviously only has hourly capacity, it doesn't show you the process time. Okay, so the easiest way to work with a similar problem is to mark down your process time for each processes when the hourly capacity of each processes is provided, or vice versa. So you have all the process time presented in the Excel spreadsheet like this. So we can start from here. So this is the way you see from the solution sheet I shared this morning, but as you can see that there's some mistake I have made. I left it as is so that we can take a look at as we study this thing together. So bottleneck process is obvious. It's a process that takes the longest amount of time to complete, which is process F. Okay, so F is the bottleneck process. So the bottleneck time is 12 minutes or 1/5 an hour. Okay, and then your throughput time is not 12 minutes. I don't know what I was thinking by the time I do this. The throughput time is basically amount of time all the components are going through entire system, right? The only thing different is you just uses a concurrent process branch which has 3 different activities, with 6 minutes being the longest amount of time. So I would 6 minutes. Let me revise it quickly. 6 minutes plus and another 6 minutes plus 3 minutes. Okay, and then 12 minutes. So I believe this will give you 27 minutes. So 27 minutes is the throughput time, is your throughput time. So I hope you still remember what's the difference in terms of concurrent activities or parallel activities and how times are calculated differently in terms of what you are looking for. So when you calculate throughput time, the longest time is taken to complete one of the activities in a concurrent branch is considered as the process time for that particular branch. So for that reason, we're adding 6 from A, B, and C, and a second 6 is coming from D. The 3 is coming from E. So even this is a parallel, we're still using 3 because that's the amount of time you have to go through that particular system, right? And lastly, it's 12 minutes. So it's total 27 minutes. Okay, so I apologize for this little mistake I made if I made it confused, but the correct answer is actually 27 minutes. So the weekly capacity is 80 because currently the hourly capacity of the system is 5 counts or 5 units per hour. How so? Because remember, F is our bottleneck process. It gives 5 units per hour, right? Therefore, 5 units per hour is your hourly capacity of the system. You multiply 4 hours per day, you multiply 4 days a week. Okay, so this is 5 counts, 4 hours, 4 days, counts per hour. Yeah, if you want to get detail about it, I can keep going. And it's going to be 80 counts in any given week basis. Okay, and that's everything you need from the capacity analysis part. And then next analysis will be based on this particular result. In general, the longer the customer waits, the more likely he or she gets upset with the process. Which process has the longest wait time, therefore is most likely filled with an angry visitors. So it's very obvious that the process between E and F will have the biggest buffer, right? Because hourly capacity of E is actually 60 counts per hour. I hope this makes sense to you, right? Each process, each station your hourly capacity is 20 counts. Then you have 3 of those stations cranking up any given time. So in every 60 minutes, you have 60 counts being completed, whereas your level 2 clerk review only be able to get 5 counts done in any given hour. So there is going to be a huge delay in between. Okay, so your answer may vary. These are some of the tips coming from your textbook that basically tells us what to do to mitigate this type of problem when you see a very big constraints in your system or bottleneck in your system. So release work orders to the system at the pace set by a bottleneck capacity, meaning you assign a doorkeeper, and doorkeeper will only allow a customer to enter in every 12 minutes. Okay, that's following the bottleneck time of your bottleneck process, which is 12 minutes. So you just only release each customer in 12-minute intervals. Release customers in every 12-minute intervals. That's one approach you can do. And lost time at the bottleneck represents lost capacity for the whole system. Yes, I agree with that. Increasing the capacity of a non-bottleneck station is mirage, right? In other words, it won't help if you try to improve those hourly capacities in those processes, which are already very fast enough. So increasing the capacity of the bottleneck increases capacity of the whole system. So you need to try to increase capacity in here. That sort of should be the conclusion, or some of the perspectives you will be using to try to mitigate the problem. And number three is they're trying to do cost benefit analysis. So let's take a look. Due to the recent domestic migration, the office is considering increasing the capacity of the office by 100%. So they're trying to increase the capacity office by 100% to meet the surging demand, right? So basically, so far, our weekly capacity is 80, and I believe it's 80, right? It's 80 counts per week. You'd like to make it 160 per week, meaning you're increasing by 100%. So naive proposal, which can be pretty common, right, says just simply double the hours of operations each day, okay, and then I think it's all days instead of weeks. That makes more sense. Okay. If you wanna do that for a month, I think you can just basically times 4 weeks to a month, but because our end unit is the same, I don't think that matters. You can either do this in a day level analysis, week level analysis, and month level analysis. The magnitude of increase won't make too much difference. Okay, so I'm gonna do it in a day as a base unit. So this is I'm first trying to figure out what is the baseline system cost, the cost that goes into the baseline system before it goes through any type of changes or improvement. So you have 7 people making $30 per hour, 1 person making $120. So this is the per hour cost. You have 4 hours a day. You work 4 days a week. So this is going to be $5,080. I say this is a per week. Okay, because I'm solving in a per weekly basis. And the increase in the total cost per week under the naive proposal, basically you're asking everybody to work 2 times longer, right? So this is basically the amount of increase in the total cost. Okay, so but my approach is that, let me highlight this first. So my approach is to only add 1 level to clerk. If you have done the capacity analysis thoroughly, I believe that this conclusion is something very, very obvious and immediate. So currently the level 2 clerk, the hourly capacity is 5. The next slowest process is actually still 2 times faster than level 2 clerk. So if you add additional level 2 clerk so that F becomes a parallel process completed by 2 level 2 clerk, each working in hourly capacity of 5. That actually doubles your system capacity. Okay, even with 2 clerks working at the same time, this is still considered as a bottleneck because 10 is sort of the slowest tempo in the entire system. But still, we can double the hourly capacity. I hope that makes sense to you, okay? If that doesn't make sense, please pause for a second and consider why adding additional clerk for F process to make a parallel process helps the hourly capacity of entire system doubled. That needs to make sense to you before you move on any further. So that's the proposal. So under my proposal, instead of asking everybody to work 2 times longer, I'm only adding 1 level 2 clerk in order to expedite, to improve the hourly capacity for the bottleneck process. So my cost increase is going to be this. So if you have done all the way until this step, you're done a very good job. Okay, but if you want to go 1 step further, this is what I would have done. So 120 minus 30 times 2. As you can see, I'm getting rid of 2 employees from this photographing process because this is already too fast when compared to other processes. In other words, this is making other people look really bad, right? So when other people are struggling with a 10 or 15 counts per hour, this guy is talking about 60 counts per hour. So your process time here for the photographing station is actually 1 minute, one minute for each count. So if you eliminate 2 from existing 3, you are still fastest, but you are not becoming a big contrast when compared to other processes. Okay, that is my approach. So 120, you're eliminating 2 from the baseline level. Therefore, this is actually your total cost increase. You're saving from somewhere else. You're adding because of level 2, and 4 hours a day, 4 days a week. That gives you 960 increase each week. So in terms of magnitude of increase, my proposal only increases 18% while allowing the hourly capacity to be doubled across the entire system. But you think about the naive proposal that only increases, that increases the hourly capacity by 2 times, which is just fine, but the proposed cost increase is going to be 100%. So 100% to 100%, in my case is 18% to 100% improvement. So this is sort of analysis we can do based on the capacity analysis.